All right, good afternoon, everybody. Welcome back to another live stream. Hope you've all had a great day so far. So today we are going to be covering another topic that is not directly AI related, but it is AI adjacent. It's kind of like how we covered OAuth a couple weeks ago, where OAuth, again, is important for things like agentic AI, but not exactly limited to agentic AI. OAuth is applicable to many different things. And so OpenTelemetry is the same thing. So let's a little bit of a context for why I'm interested in OpenTelemetry specifically. And then we'll kind of set aside all the AI stuff and just focus strictly on OpenTelemetry in general. And we will be doing live coding, of course, but we're going to be doing it outside the context of AI. We're just going to be coding a more simple kind of API. So let's actually just jump into what telemetry, well, I'm sorry, I'm getting ahead of myself. So agentic AI. So what do we know about agentic AI? We know that the intention behind agentic AI is being able to give an AI agent the autonomy to be able to make decisions on our behalf. So typically speaking, we'll provide it like 2 or 3 different tools, or well, not 2 or 3 different. It could be any number of different tools that it could need to use. Maybe it's retrieving context from some sort of custom sort of proprietary database or something like that. And even though we are giving out these multiple tools, in typical programming, we typically program things sequentially or like with conditional logic. With agentic AI, because AI can reason through things, it can select whatever tool it needs to use at the time when it believes it needs to use it, which can pose a bit of an issue if you think about it. Like if you're not coding an agentic AI system correctly, then it could maybe misuse a certain tool at a certain time, or maybe it's doing things in an unideal fashion. Maybe it's taking 20 to 30 different steps when it can maybe take 5 to 7 different steps. But it is unless you are setting up your what we would call observability correctly, then it's kind of a black box, and we don't necessarily know what steps the agent is taking. So where telemetry is important for agentic AI specifically is we can capture that full story of, okay, when the agent received its task, it took this step, it took this step, it took this step, it took this step, etc., and then it completed. And having that telemetry captured of what the agent did can help us inform us how we can maybe optimize the system, how we can correct for errors, etc. And so naturally, that is not necessarily limited to agentic AI. That is also important for basically any other kind of software application. So if you are developing a website and you want to know how many people have hit a certain web page, or if you want to capture logs to be able to debug like an API later down the road, there are many different forms of telemetry out there. And so actually, let me go ahead and share my screen. Now, so this is the repo I've started to create here. You can find it on my GitHub page. It should be toward the top there. It's just called OTel tutorial. So what I want to cover here is I went ahead to Wikipedia and grabbed this definition of telemetry at the top here. And I do kind of like this definition. Let me go ahead and read it out loud. So telemetry is, now I don't know what in situ means, to be honest. I think that's some Latin term. Is the in situ collection of measurements or other data at remote points and their automatic transition to receiving equipment for monitoring. The word is derived from the Greek roots tele, which means far off, and metron, which means measure. So I like let's call out a couple of things here. So first thing, we already kind of talked about this one a little bit. Collection of measurements or other data here. So naturally, when you think about agentic AI, we're thinking about the full trace of like what the agentic AI did. And if you're not sure what a trace is, we'll get into some of these definitions. I'm trying to avoid the definitions for now because if you don't know what they mean, then it can be a bit confusing. But we will define clearly like the specific terminology that we use with OpenTelemetry. But the thing to keep in mind here is that when it comes to software applications, well, I'm going to ahead of myself again. I do want to call out also here, remote points and their transmission for receiving equipment for monitoring. So remote points, well, what does that mean in this context? So generally speaking, when you are setting up telemetry on a software application, you are having that telemetry being sent to some other source that is generally not on the same hosted instance or same hosted server. That's not to say that you can't have your telemetry hosted on or being sent to the same server or the same instance. It's just that in most cases, like in a large company, for example, they're going to have many different APIs, many different websites, many different Java applications, etc. And generally speaking, it's ideal to have all your telemetry go to one location. That way, you can have data scientists or data analysts or whomever else kind of have a single source of where to send that telemetry. So, big companies that maybe you've heard of before, Datadog, Dynatrace, or even on AWS, there's like CloudWatch, etc. There's all of these accept telemetry. In like a centralized kind of manner. So remote point, and then you have the automatic transmission. Where we are basically sending that information live. Well, I mean, you can kind of set it up different ways, but generally speaking, you don't want to have your API running out there, like an API, for example, running, and then like maybe once a month the telemetry is collected. That's not ideal, because if the API goes down, you want to know immediately that something is going on here. So somebody put in the chat, in situ is a Latin phrase meaning in the place. Okay, cool. Thank you for that context. By the way, I am accepting questions on YouTube or LinkedIn. There's about a 20-second delay, so apologies if there's like a little bit of a delay there. So that's like the general definition of telemetry. But here's the thing about telemetry. As you can imagine, with software engineering, I mean, we are naturally, there's many different programming languages out there. We got Python, we got Java, JavaScript, Go, Rust. There are many different ways you can code your how you capture that telemetry, and that can be a little bit of a problem. In especially in the sense, like, if you want to collect all like this telemetry from multiple different sources. Let's say again you're working for a big company and you're maintaining like 50 different APIs. What you don't want is 50 different ways that people are sending their telemetry to you, because then that makes it really hard to gather analytics, especially if you're trying to gather analytics across all 50 APIs, like in a standardized kind of way. It's just not ideal for people to be sending all of those in many different ways, because then you got to manage like 50 different ways of doing things. And so that is the whole intention behind OpenTelemetry. OpenTelemetry is this open source concept where we basically are applying standards to that information or that telemetry that we are collecting from our software application. So that way we're not necessarily having to worry at that centralized source when we're gathering that telemetry, that we're not like our data is not like a crazy different format every time we're receiving it, whether it be from API A, API B, API C, etc. So that is the general concept behind telemetry. So I hope you can gain an appreciation of why telemetry is important, both for the general software engineering context and then more specifically the agentic AI context. And that kind of ends where I'm going to talk about agentic AI today. We're going to step more now into just raw, well, I don't want to say raw, but like just general OpenTelemetry. And again, we're going to be applying this in code by coding up a FastAPI API, but we'll get to that in a second. So let's talk about OpenTelemetry, and then specifically what are these things called signals. So I'm actually going to go to this site here because we actually have a different these different kinds of signals here. So what is a signal? A signal is basically a categorization of a kind of piece of a kind of information that you are wanting to collect. Now, OpenTelemetry here notes 4 different signals. I'll cover these first 3 more in depth here, but I do want to touch on this 4th one really quick. And maybe this is just my misunderstanding. I don't really see how baggage is a signal. Well, actually, let me talk about these first three first, because maybe it'll make sense why I don't understand why baggage is a signal. So first here is the traces, and traces are really easy to understand when you think about that agentic AI context. So with a trace, that is basically telling the story of what actually happened from start to finish with maybe it's a single API call, maybe it's a single instance of the agentic AI completing a task. So when you think about agentic AI specifically, recall that if we provided a number of different tools that I can invoke, we want to be able to see, okay, invoke tool A first, then maybe tool C, then tool B, then maybe tool D, etc. And so that is what we would refer to as the trace. And then specifically under the traces, each of those individual units or those steps that we are taking there are referred to as spans. So those spans does not appear up on here because it rolls up under traces. We're going to be working a lot with spans here today. So that is trace. Now I'm going to skip over metrics for a second just to contrast that with logs, because you might be wondering what is the difference between trace and a log. So traces, again, remember, we're trying to tell the sequential story of here's what happened at the start of our journey, here's the path that we took along our journey, and here's where we ended up on our journey. Logs are not necessarily concerned with that kind of thing, but logs are still important for a different context. So many times when people are using logs, they're using it for debugging purposes. So it would be things like if I'm calling out to a SQL database and I receive some sort of error, we want to be able to log that. That way we can go, like if we continue to see some sorts of problems, then we can go into the logs and leverage those logs to understand, okay, what actually was going on here? Why was something successful? Why was something not successful? And you can kind of imagine that these two traces and logs play a role together, where you might, with agentic AI, for example, you might want to see the specific trace, all the spans that represented, we invoke tool A, then tool B, then tool C, etc. Whereas the logs themselves would say, okay, tool B was a SQL tool that was reaching out to some sort of database and there was some sort of error. Let's check the logs associated there. So kind of a play there. And I guess I should say, I'll hold off on that for a second. So that's traces, that's logs. So let's jump back to metrics. Metrics are pretty easy to kind of understand. It's measurements that you want to capture. Generally speaking, these are numerical measurements. So you can imagine maybe this is number of times that your API has been hit. But it's not even just raw incremental measurements. You can also capture data that you can represent later as histograms, and we'll actually demonstrate that within our code here in a little bit. So those are our three different signals. And again, I hope you can understand why they're referred to as signals. Is because we are trying to signal to whomever cares about our telemetry of the different kinds of things that we're trying to signal to that individual. So traces would represent the story, logs would represent different individual parts of the application and how they're doing, and metrics would give those numerical measures or histogram measures, etc. Of those things. So back to baggage then. I don't understand why baggage is listed here as a signal, because baggage is really just a way to capture information or telemetry information that maybe we'll use in another part of our script somewhere, and then we can make use of that baggage elsewhere across traces, metrics, and logs. So baggage can be helpful to support traces, metrics, and logs, but I don't understand why it is called out as an observability signal in and of itself. I see it. I don't want to say that it's not valuable, but I see it more of as a support, because it's actually just a key value store, and it's so I've been working through this, of course, with AI. I use AI just like I use Google these days in terms of research, and I was asking the AI last night, why. What's the difference between a baggage here for OpenTelemetry and just a standard Python dictionary? And it basically said it didn't give a good firm reason why we should want to use baggage over a Python dictionary. Which is not to say that there's not a reason why you'd want to use one over the other. But all that to say, so we are going to be with our application that we're going to be coding up today, we're definitely going to be making use of traces, metrics, and logs, but we're not going to be making use of baggage at all. Okay, so that is the core of what I want to cover with OpenTelemetry today. Now, I want to. There was another. So this is a little bit of an ambiguous diagram, but I do want to cover here really quickly. Ambiguous just because there's no words on it. But basically, you can see that OpenTelemetry, represented by the telescope here, sits at the center. And so I'm trying to recall if how do I want to read this? Maybe this isn't the best diagram. Let me find a different diagram here. Docs. Okay, yeah, this one's a little bit better. It's a little bit much, but it's still better. So what we are going to be covering today specifically is, so imagine that we have our API that might be represented as a microservice over here. So naturally, as we code up that API, we are going to have to package up our telemetry in a way that makes sense to us. And so that is something that I did want to cover here, because you might be wondering, well, is this required for our application, whether that be a website, API, etc.? And the answer is no. None of this is required at all, which is not to say that you shouldn't do this. But it's one of those fine dances of you have to determine what is important to you. So it may be that you have a capture of traces and a capture of logs, but maybe no capture of metrics, or maybe you're only capturing logs and metrics but no traces. That's going to be up to you. Now, for our example today, we are naturally going to go through all three, and in fact, I'm going to say we're going to go a little bit overboard, and that's intentional. It's to help us learn here, but it's going to be up to you to determine what kind of telemetry that you want to capture from your application. But anyway, so we actually have to set that within our code here. So we're actually going to be using the Python SDK, OpenTelemetry SDK today. And then in terms of agentic AI and stuff, there are abstractions on top of that. And I think that we're going to cover those in future streams, not as part of this two-parter stream here, but maybe I'm tempted to do a series of streams on the various agentic AI frameworks. But if you recall from a previous stream, we actually did touch on this a little bit with the Strands framework. So Strands actually does have this abstracted version of telemetry that kind of makes things easy to apply telemetry specifically for Strands agents. And that is all just sitting on top of OpenTelemetry. And so there's LLMetry, and then there's a couple of other abstracted versions, but they're all sitting on top of OpenTelemetry. And it's not particularly required that you use those. They can be helpful for sure because they are abstracted versions. But if you want of OpenTelemetry, but if you want to get down to brass tacks, then we're just going to use OpenTelemetry directly with the Python SDK. So as you can see here, though, so we have observability front-end APIs. I'm a little bit confused by this diagram here. Maybe this is not the best diagram for me to work from. But basically what I was trying to illustrate here is, so with our API, so recall that we are sending our information to a remote location. Maybe that's Dynatrace, maybe that's AWS CloudWatch, something else. So what we would have in the middle, I don't like this diagram because I'm getting confused by it. So I'm gonna roll with this one, but I don't really like this one either. I should have created my own. I should have looked at these beforehand. I apologize. But anyway, so let's imagine that these represent our APIs here on the left. So here we would, as part of our API, we need to denote what we want to capture here in terms of our traces, logs, and metrics. And then we are going to send them to a collector. So this would be OTel at the center. So that's going to, so imagine that we're let's imagine that we are trying to send a package out through FedEx or UPS or something like that. So imagine that here we're actually defining what we're wanting to put in the box, and then OpenTelemetry would be putting the stuff in the box, and then we would actually be shipping it off to one of these downstream locations. So this again could be Dynatrace, could be Datadog, could be We're actually going to be using something called Signos, which is like an open source thing, and I'm only doing it just because it's open source, but we're not going to be touching Signos at all here today. We're going to be doing that as part of part 2 of the stream. So where we're actually going to focus our attention for the rest of the stream today is just on this first part of how do we actually apply the OpenTelemetry to our FastAPI API in Python, and then in the next stream we'll cover this in more detail how we would actually export those that telemetry with OpenTelemetry and then send it to a downstream location. And again, that downstream location for the next stream is going to be this open source framework called Signos. Okay, so that's kind of OpenTelemetry at a high level. Let's actually get more specific with actually doing some real life coding. And to be honest, there's going to be a lot of code here today, and I don't know how much I actually want to hand write, or I'm sorry, not hand write, but like live type here, or versus copy and paste. So I do want to harken back here that I do have this GitHub repo. It is still a little bit of a work in progress here, at least as of today, as part 1 is airing. Now, by the time that part 2 airs, the intention is that this whole repo will be complete, and then you could see that I'm basically kind of covering the same things that we covered here today, talking about like the different signal types, talking about why baggage confuses me, etc. And I'm going to continue building this out. And you can see that all the quote-unquote completed code is going to reside here in this SRC directory. But what's not here right now, but I'm going to add here in a second, is I'm going to add a new directory in here called stream, just so we can keep track of what we're doing right now. That way, because what we're going to be doing today is actually going to feed into the next stream. And so this is going to be a little bit of a strange stream in the sense that, like, by the end of this stream, we're going to have a working FastAPI instance, but we're actually not going to have the telemetry. We're not going to have the telemetry in a state where we can actually go and view it and such by the end of the stream. That's actually going to come in the next stream, which hopefully maybe the next week, next 2 weeks, we'll get back to this. Okay, so what are we building today? I mentioned that we're building a FastAPI API. So what we're actually building specifically is we are building basically, like, imagine that we are a pizza restaurant, pizza shop, whatever you want to call it, pizza place, and we want to be able to accept pizza orders. So we are going to have basically this API where a customer could, or a downstream client, maybe it's in behind the scenes, it's like a iOS application or an Android application or something like that. But basically, when you put in your order, then you would send it up to our API. We process it through the API, and then along the way, we're going to capture a lot of telemetry. Now, I actually do want to go ahead and show the code really quick, just to highlight something really quick, because there's actually not much to the logic of the API itself minus the telemetry, but you might see really quick here. Most of this code is OpenTelemetry code, just to capture telemetry. And you might be thinking, well, is that just bloating my code unnecessarily? And again, I just want to remind you all here that we are intentionally going a little bit overboard here. In a real life, like if I was actually building a real life pizza API kind of thing, it's probably going to be a little, the logic of the pizza stuff itself, or the business itself, is probably going to be more complex. And again, we're going to go just crazy overboard on capturing information. I don't know in reality that I would capture this much information. Okay, so with that, let's go ahead and jump into our IDE here. So you can see here underneath the source directory, I've got 4 files. It's probably hard to see there, so let me show here. So we got 4 different files here. I am going to populate this OTel config file today, but we're not going to actually talk about it today. We'll talk about that in the next stream. But we're going to spend most of our time focusing building the API itself, and then the helpers file here is just me taking some of the business logic functions and then placing them here, and that way we can make use of them for the API. I could have put them all in the same file. It's just that started to make the file really long. And then down here, I'll go ahead and show you this. So this is basically representing what our menu would be, and prices associated to the menu. So for example, you could see here that like let's say I ordered a small thin crust pepperoni pizza. So small would be 10, thin crust no additional cost, and pepperoni is $1.50 here. So $10 plus $10 plus $1.50, $11.50. So that's what the cost would be here. Very simple. And in fact, we're just going to copy and paste that here. So let's go back into the ID here. Let's go ahead and start to set up our directories and such appropriately. All right, so I'm going to do clear. Okay, so I'm at the root of my repo now. All right, and I'm going to do make dir stream. And then I'm going to cd into that stream directory. And then you can see off on the left in my Explorer that it's already it's already created the directory over here. I personally just like to populate files this way. Like, you can do it through the user interface here. I just find that it's faster and easier to not remove my hands from the keyboard. So I'm going to do touch OTel. Well, I'm going to call it stream OTel config py, just so like we're not getting extra confused here. Touch stream pizza API.py, touch stream pizza helpers.py, and touch stream pizza menu.json. Okay, so now I'm going to go ahead and collapse this. So if I toggle open this, then you can see that I have created empty versions of all these files. Now, a couple of these, like I said, so for the OTel piece, I am just going to copy and paste this now for now, because we're going to revisit this at a later point. Next week as part of part 2, so we're going to ignore this for now. I can't remember if this is actually necessary or not for the code that I'm writing to like just make sure that the API itself is functional, but just to be safe, let's go ahead and throw it in there. And then same with the pizza menu. It's pretty basic here. I don't think there's any particular requirement to manually write all this. And by the way, I mean, technically speaking, I could just copy and paste this entire stream. I personally find that, yeah, we got AI coding tools today that are very helpful. And I transparently, I did have the AI help me like write the initial script, but I personally went back through and rewrote the entire thing line by line, every single character myself, because I just find that's a way to help me learn. It really helps me to ground for the knowledge here, and it was so I just did that last night. Spent a couple hours doing that, and watching YouTube on the side, just because, like, I don't know, that's my idea of a good Thursday night, I guess. So let's go ahead and just copy this. We're going to copy this into our pizza menu here. Now, these other two files, we'll see how much I feel like typing versus copy pasting. But let's go ahead and jump into our API itself. So the API itself, we got a lot of stuff we got to do here. Hold on, let me switch views here on my bottom screen so I can have stuff to reference. All right, so we are going to need to do a lot of imports here. So we're going to first importing base Python libraries. So these are Python libraries that come directly integrated with your Python installation. In fact, let me make this a little bit bigger for y'all, just so you can all see extra clear. Okay, so importing, so from future import annotations. All right, we need to import JSON. We're going to import logging. We're going to import time. We are going to import this context from the context lib, this async context manager. We're going to use path from pathlib. And then import from typing import any. Okay. I also should have noted here that if you're curious, like all the third-party libraries that we're going to be using, so I really like UV these days. So I'm working out of a UV virtual environment. So as part of my my GitHub repo up here, and I'll just show it up here in this interface. So I got this PyProject TOML file. This is basically everything that you're going to need here. So if you're wondering like what sort of dependencies you need, I would actually just encourage you to use UV and then just do a UV sync, and then you'll have everything that we need. And so you can see here, let's just talk through this really quick. So we have FastAPI, and then generally speaking, whenever we actually host a FastAPI instance, we do that with Uvicorn here, which is why Uvicorn is present. We are going to be toward the end of the stream using PyTest to basically leverage unit testing to actually test the functionality of the API. Naturally, of course, we're going to be using OpenTelemetry, so that's why OpenTelemetry is here. I can't remember why HTTPX is here, but I want to say that has something to do with OpenTelemetry. And then we're going to be using Pydantic. And if you're not familiar with Pydantic, Pydantic is basically a way to help like create a data model that adheres to specific data attributes. So for example, if I'm capturing the subtotal cost of like all the pizzas that we're trying to make for like a given order, then that's we want to ensure that that's a float value and not an integer value. And then we may even be more specific than that and say it's got to be a float with two decimal places. Naturally, just because, you know, whenever you think about money, we have dollars and cents. It's not going to be like a straight integer value there. And so Pydantic helps us to adhere to those data models. And you'll see that here in a little bit of those data models that we're going to be creating. All right, so let's get back to our imports. So importing third-party Python libraries. All right, so from FastAPI, we're going to import FastAPI and request. From Pydantic, we're going to import base model field. Oh, one kind of, do I want to make this comment or not? Yeah, I guess I will. So I've actually turned off autocomplete completely, even just for my own research work. I've found that I don't want to say that autocomplete's bad. I've just gotten tired of it. Like I've gotten tired of wanting to type something and not knowing if maybe this just is like a VS Code thing that I need to do. But like, well, let me show here really quick. So when I start to type out like from OpenTelemetry, you can see here that I'm getting, like, if I start to type out metrics, then I'm getting a suggestion of what I could import here. This is not an AI suggestion. This is just like a VS Code recognizing that within OpenTelemetry, there is this thing called metrics here. I just got tired of autocomplete trying to figure what this is actually supposed to be, and I just prefer this. So I've actually turned off autocomplete completely now, which is not to say I don't use AI coding tools. I definitely do. It's just, I don't know. I've gotten really tired of babysitting agentic AI lately, at least in terms of coding tools. All right, and then finally we're gonna importing our own custom code. So from stream OTel config, we're gonna import configure OTel, and then from stream pizza helper. So these are two of the respective Python files that we created over here. From stream pizza helpers, import star, because we're going to be creating a number of different Python functions over there. All right, so that's all of our imports. Now let's move on to doing a couple of different things like a data load and a data model ingestion. So the data load here, all right, and I like to do, this is like my own version, like my own flavoring of like a header, I guess, within a Python script. So first things first, we need to load up the pizza menu. So loading the pizza menu. So I'm going to call this pizza menu equals json.loads pizza menu.json. All right, and then so along the way here, we're going to capture, this is, again, very naive. Like this is probably, I would never actually recommend this in real practice, but like if you wanted to keep track of order history, like all the different pizza orders, you naturally want to send that to like some sort of downstream database. To keep things simple, I'm just going to create a Python list here called pizza orders, and we're just going to append things to it. Now, obviously, so like this is going to be ephemeral, meaning that this is only going to live for as long as the API lives. So again, but we're just doing something for demo purposes, but in reality, the order should be going to some downstream database. All right, now we were talking about those Pydantic models earlier, so let's create two Pydantic models here, data models here. So one is going to be a data model of what are we expecting from the downstream client. So we're going to call that pizza order request, and then on the other flip side of that, what are we expecting to give out to as the the response of the API. So we're going to call that pizza order response. So the first one here, we're going to call this class pizza order request base model. All right, and then we're going to have a couple different attributes associated with it. So we need the size of the pizza, of course. There's going to be a string. So we're going to call this a field, and we're going to give it a description equals small, medium, or large. Okay, next up, crust. Remember, we got thin crust, original. I think it's thin, original, and thin original. No, I'm sorry, thin hand tossed and deep dish. This is making me hungry. I ate breakfast. I ate breakfast, but I didn't eat lunch today because I was full from breakfast. But now that we're like at 2:30 in the afternoon, this is making me hungry for pizza. So okay, crust string equals field description equals thin hand tossed or deep dish. Okay, next up we have toppings. So we're gonna have a variety of toppings here. So let's flip back to our menu here. We got pepperoni, sausage, mushrooms, onions, green peppers, black olives, extra cheese, and pineapple. But we're just gonna represent these as a list. Equals field default factory equals list. And then finally we're gonna have our quantity. How many pizzas are we actually gonna be making? So we're going to say this is going to be an integer value, of course. Not filed, field. Default equals 1. Now, I didn't look this up. I should have looked this up. I don't know what GE stands for or what LE stands for, so I apologize for that. I'm sure that it's probably something rather simple that I could have figured out. All right, so that represents the incoming request. So let's create a class here for the pizza order response base model. Okay, now we are going to provide an order ID as an integer. We're going to give the size as a string. We are going to do crust as a string. We are going to do toppings as a list of strings. We are going to give the quantity back. Quantity. That's going to be an integer. Price per pizza. It's going to be a float value. Subtotal. That's going to be a float value. Prep time in seconds. This is actually going to be a float value. I can't remember why it's a float value, because I think it might be not exactly like full rounded seconds. Okay, same idea for bake time. So we're gonna separate prep time from bake time. Call it a float, and then total. Oops, not float. And then we're going to have total estimated time seconds. It's going to be a float. And then we're going to have a status. And that's going to be a string. All right, so that's our Pydantic data models here. Now we're ready to start getting into the OpenTelemetry configuration. And again, this is we're gonna skip out part of this for part 1 today. We're going to write the code, but not necessarily going to cover like what it means today. I'm going to call this OpenTelemetry setup. All right, so first we need to initialize our OpenTelemetry configuration. Now let's just glance over here really quick. So I actually do have basically just a Python function that's doing the configuration of the OTel. And again, we will get back to it here in the next stream. But for today, all we need to do is just call it here, configure OTel, and then that's it. And then, so we'll get back to that as part of the next stream. But what we do need to do here is recall we have our 3 telemetry signals here that we're going to be focused on of traces, metrics, and logs. So we need to instantiate a couple things that will actually be like containers that hold those respective things. So we are going to instantiate our tracer. We're going to call that trace.getTracer. And you might be wondering, where did I get trace from? That is from OpenTelemetry up here, just as a reminder. I'm going to call this pizza API.tracer. We're gonna instantiate our meter to capture our metrics. So metrics.getMeter We're going to call this pizza API dot meter. And then finally, so actually Python, in terms of Python specifically for OpenTelemetry, there's not, you might recall, well, we just instantiated these things of the tracer and the meter using OpenTelemetry. For the logger, we can actually just use Python's default implementation of the logger. So we're going to say logger equals logging.getLogger. And we're going to call this pizza API. All right, so that is at a very high level how we start to configure the traces, the metrics, and the logs here. But we're going to need to be more specific with the rest of the parts of our code on what we actually want to instantiate. So this is where things start to get a little bit much, and I'm not sure how much I want to hand type of all, or manually type of all this, but we'll keep going until I get tired, or if it just seems super redundant. But first thing that we want to do here is we're going to set up a bunch of different meters here. And again, we're going overkill here. We don't need to do this many, but again, I really want to drive these points home. So let me just read off all the things that we're going to capture in terms of metrics. So we're going to capture the number of HTTP requests that we get. We're going to capture the duration of the HTTP request specific, and then save those as like a histogram. We are going to create a counter for how many pizza orders we got. We are going to create another counter that's going to track the overall revenue of how much we've received, how much we're getting in terms of pizza revenue across all the orders. We are going to capture another thing that another histogram kind of thing that represents like the distribution of all the subtotals in case we want to see, you know, are people buying like 8 pizzas? Are they like 8 pizzas with deep dish, etc.? We just kind of want to get a sense of that. We're going to capture another histogram that's going to represent the bake time, and we're going to capture another histogram that's going to represent the prep time. So that's 7. Do we need 7? Maybe. This is going to be up to you. This is going to be specific to your application. We're going crazy here intentionally just to kind of help drive the knowledge home. So we have a lot of these things to write. Okay, so first up, the HTTP request counter. HTTP request counter equals meter dot create counter. Okay, so we need to provide a name of how this is going to manifest in our OTel log. So we're going to call this http.server.requests. And then we're just going to provide a description equals number of HTTP requests. Okay. All right. 1 down, 6 to go. HTTP request duration equals meter dot create histogram. Histogram. All right. Name equals HTTP dot server dot duration. Description equals duration of HTTP requests in milliseconds. And then we can actually set a unit on here. Unit equals milliseconds, ms. All right, 2 down. Next one up, pizza order counter. How many pizzas orders have been placed? Pizza orders counter equals meter dot create counter. Name here is going to be, we're going to call it pizza.orders. Description is going to be number of pizza orders placed. Oh, I should have noted also, if you're wondering like why there's an air noise going behind me, it's because I have my space heater going on because I'm in my basement and it's cold and it's Illinois. And Illinois can't, like Illinois is like the Midwest always has variable weather, but it's been like very variable lately. Like it's like yesterday was, or 2 days, was it yesterday? It was like 2 days ago, it was like 90 degrees, and today it's like 45 degrees, and it's been yo-yoing like that for so much. But anyway, always cold in my basement about this time of year, so that's what that air noise is behind me. Anyway, so next one, pizza revenue counter equals meter dot create counter. Name is going to be pizza dot revenue, and then oops, did I put a comma there? Nope, I did not. Description equals total pizza revenue. And we're going to capture that in US dollars, in USD. And then we're going to set the unit equals USD. I think I forgot a comma there again. I did. Okay. All right, 1, 2, 3, 4. 4 down, 3 to go. 1, 2, 3, 4, 5, 6, 7. Okay, just want to make sure I have my count there correct. All right, so next up, pizza order value histogram equals meter dot create histogram. Name equals pizza dot order value. Description is going to be distribution of pizza order subtotals in US dollars. Forgot the comma again. And unit is going to be USD. All right, 2 more. All right, pizza prep time histogram equals meter dot create histogram. Name equals pizza dot prep time, and then description equals estimated pizza prep time in seconds. Our unit's going to be seconds. Unit equals S. And then our last one's going to be just the bake time. It's going to be the exact same as this. I'm just going to copy and paste and change a couple quick things here. So I'm going to change this to bake. I'm going to change this part to bake. Not bail, bake. And this also to bake. Okay, there we go. All right, there we go. That's all of our 7 metrics. Now, again, these are not collecting these automatically. We do have to be explicit within our code of, okay, when do we increase our revenue counter, or when do we increase our pizza orders counter? We'll get to that as part of our code here. So let's keep moving on. Now, let's move on to the FastAPI setup. Now, I do want to cover something here. We've covered FastAPI as part of previous streams before, but something I had never actually used before is this idea of middleware. And so, as the name implies, middleware is this basically a what's going on in the middle, like what is going on, so let's say we have a call coming into our API, and we have like our logic of our API doing stuff going on behind the scenes. So obviously, the reason that we use that FastAPI is because we don't want to have to code up our own API. So there's like an abstraction going on in the middle here, and so we can actually add some stuff to that middleware layer for our OpenTelemetry here. And so the reason I note that is because like whenever we want to do things like the HTTP request counter, that might actually be nice to slide as part of the middleware instead of actually having that as part of each of the respective endpoints. That way we're not having to like duplicate or triplicate like each of the endpoints. And I guess I should have led off with that. So we're actually, you'll see this in a few minutes, of course. I see that I missed another comma up here. We're actually going to be creating an API with 4 different endpoints. So the 4 endpoints, 3 of them are going to be get endpoints. So we're going to have an API, a get endpoint for just retrieving the menu. If you want to see the menu, we're going to have a get endpoint just for health check. That's a pretty standard practice. We are going to have one to get statistics associated to all these metrics if we'd like. So those are our 3 get endpoints, and then our big hefty 4th one are going to be our post endpoint. So that's going to be our order endpoint, and that's going to be how we facilitate basically the core logic of fulfilling the pizza order. And so where was I going with that? Oh yeah, so back to middleware then. So because we have those 4 different endpoints, and we are interested in capturing all of the number of HTTP requests, regardless of whether it was a get to the menu endpoint or a get to the stats endpoint, it's nice to add this to the middleware layer instead of just applying this individually to all of our 4 respective endpoints. Okay, so I'm gonna call this here. I'm gonna create another thing. Let me switch back to my other view on my other screen. Okay, so I'm gonna call this FastAPI setup. FastAPI setup. Some of this is gonna look familiar. Some of this is gonna look new. All right, so the first piece of new thing. So we need to set up this what is called the async context manager. And this is really just going to help to log when the API is starting up and when it's shutting down. So we're going to call this async def lifespan, and we're going to accept our FastAPI instance as an input, and then we're going to put logger.info starting the API, and then we're going to do yield, and then logger.info shutting down the API. Now I'm going to be completely transparent. Like, so this middleware stuff for FastAPI is a little bit new to me. I'm not like an expert on understanding this specific piece here, but like I think I generally understand it. But if this part does confuse you, I just recommend you use something like ChatGPT to kind of help better explain that to you. But this plays such a small role in our code that I'm personally not worrying about trying to explain that myself. All right, so let's actually create our FastAPI instance. I'm going to call this Pizza API equals FastAPI. We'll give it a title of title equals Pizza API, and then we are going to pass in that lifespan equals lifespan here. Okay. Now let's go ahead and add this middleware layer. So I'm going to put at pizza API.middleware. We're going to apply it to the HTTP. We're going to call this async def telemetry middleware. We're going to accept our payload as the represented by the request and call next. All right. So now, recall that one thing that we do want to capture here is like a start and end time here. So that's why we imported the time library up here. So the first thing that we need to do is instantiate our start time. So I'm going to call this start. Hold on, I'm going to turn off my space heater because it's starting to get hot in here now. There we go. All right, start equals time.perf counter. All right, and then we need, we're going to get the route from the request. Request.url.path. We're going to get the method. So is this like a post or a get-in method? Request.method. And then we're going to instantiate a status code of 500, but we will be overwriting this appropriately if there's like a success here. All right, so recall here that we have our counter up here of number of HTTP requests. So this is actually how we start to apply OpenTelemetry more specifically here. So we're going to say incrementing the HTTP request counter. And the way that we do that is we have our counter dot add amount equals 1, because we just want to increment it by 1, and we're going to add some attributes here. Attributes equals, so we're going to say http.method is going to be our method. http.route, it's going to be our route. And then, so that's the metric there. Now we do want to add some additional information to our logger. So we're going to say logger.info is going to be message equals request started. And we're going to add some extras on here of the same thing up here. I'm going to copy and paste this because, yeah, we're at an hour right now, and we have a lot of code right to right left. So we will see how much we will actually get through manually typing versus just going and copy pasting. I'm going to make sure that we manually type at least one of everything, like one of a trace, one of a span, one of a logger. We've already done the metrics, but yeah, we'll just see because we're already starting to hit at an hour here. Okay, so next we're going to do try. Response equals await, call next, request, status code equals response dot status code, and we're returning the response. Then we're going to do an except block here, except just in case something goes wrong, exception. logger.exception. Again, more telemetry in action here. MSG message equals unhandled exception during request. And we're going to provide some extras again here. Extra equals these things. Route and method again. And then finally, literally finally, after that try block, finally, we will calculate the duration. Calculating the duration of the pizza order. We're gonna say pizza order duration equals, so we're gonna round it. Number equals time.perf counter minus start times 1,000. And then number of digits is going to be 2. And digits equals 2. Oh, my face is starting to get in the way. Hold on, let me move that for you. Okay, there you go. You can see that better now. And we want to record this as part of our telemetry. So recall that we have that that thing called HTTP request duration. So we are going to record our duration here. So we're going to say amount equals pizza order duration. Order duration. Pizza order duration. And then I'm going to say attributes equals, we're going to do a little dictionary here. So we're going to have our same two that we saw before, of the route and the method, and then we're going to add a third one here, status code. Dot status code, and that's going to be the status code. Okay. And then we are going to log that the request is finished. Logger.info MSG message equals request finished. And we're going to add some extras again here. Extra equals those two. Then we're going to add the status code, and then we're going to add the duration as well. And then we're going to say duration ms pizza order duration. Okay, does that complete our middleware layer? Okay, so that completes our middleware layer. Now we can finally get into the endpoints. Let's go ahead and touch on like some of the quicker endpoints first. So I'm gonna grab my stylized header thing here. I'm gonna call endpoints. Okay, so let's start with just the health check endpoint, just because this is something that's super common across most APIs. Most people have it. Like even on AWS SageMaker, for example, if you deploy an AWS SageMaker API, they expect you to have this health endpoint because that's how they when you deploy like a real-time endpoint, that's how it knows like to check for the health of the running endpoint if you're deploying it with FastAPI specifically. So we are going to call this at pizza guy.get health. All right, async def health. And then we're just going to do a quick logging the health check. Logger.info msg equals health check. And then just do a simple return status. Okay. All right. 1 endpoint down, 3 to go. That was the most basic endpoint. So the others are only going to get more complex here. The post one we're going to save for last. That one's going to be a hefty guy. All right. So let's do the get endpoint for just retrieving the menu. So pizza API dot get menu. All right, async def get menu. Okay. All right. Now here's where we're actually going to implement the introduction of traces. Although to be honest, this is kind of for this context, it's very frivolous. So the way that we do that is we're actually we're going to do this with statement. So like imagine, well, let me show back up here. Oh, I didn't do it there. Never mind. Okay. But typically speaking, like whenever you load up a file, like whether it be a CSV or something like that, you usually do this with open, then the file name, and then like write binary kind of thing. And the reason that we do that is because if you don't do it that way, then it keeps that document object open for the entire time of your, like, however your your script is running, and that's not ideal. And so we're kind of doing a similar idea here. So with tracer dot start as current span, we're going to call this get menu. All right. And then we're going to say logger dot info menu requested and return the pizza menu. Now, that's probably like an extra frivolous use of spans here, or traces and spans here. I would never actually do this. And like for real context, personally speaking, I don't see why you'd want to do this. But this is going to make a lot more sense as we get into like the actual post endpoint representing the thing that we submit our orders to. I'm sorry. Let me see here. Okay, I actually am going to do the post endpoint because the last get endpoint is one on statistics, getting statistics about everything, and I think that kind of just doesn't make sense if we do those in a weird order. And this is where we're actually going to start to introduce the helpers file. Now, again, I could, like I was saying earlier, I could have done everything as part of this singular file here, but it started to bloat the code as far as a single file goes, and I like to break the code out in a logical way that kind of just makes sense for readability purposes or understandability purposes. So we are going to start to add things to our helpers here. In fact, I might do a split right, open to the side. There we go. All right, I'm going to actually collapse this down for now. All right, so let's come on, cursor, where are you? There we go. I was trying to just resize this one thing here, and my beloved Atom 1 Dark Pro theme kind of makes that a little bit hard to. Well, you literally can't say it, but I just love this theme so much, though. That's just like a coloration of why my IDE looks like this. Okay, what was I saying? Oh yeah, we're starting to create the order endpoint. So there's going to be a post endpoint. All right, so at pizza API.post, I'm going to say order response model equals pizza order response. So recall that we created this as a Pydantic data model from above. All right, so we're going to say async def create pizza order. We're going to accept our payload as a pizza order request. Again, another Pydantic object there. Okay, now we're going to start to get into the meat of our API. Pun not intended, if you are a Beat Lovers Pizza kind of person. All right, so we're going to do starting an OTel span. Oops, I spelled that wrong, or cased that incorrectly. Span for creating the pizza order. So with tracer.start as current span, we're going to call this create pizza order as span. All right. And then we are going to log the information first. Logger, so logger.info msg equals order message equals order received. And then we're going to provide some extras. We're going to say size is payload.size. Crust is payload crust. Crust is payload.crust. Quantity is payload.quantity. And topping count is going to be the length of the payload.toppings. Okay, because we are at a a little over an hour now. I think I'm going to make the compromise of I'm going to continue to handwrite everything here, and then all the helpers I am going to just manually copy and paste here. But to be extra clear, I am going to verbally explain each one. It's just a matter of like if we handwrote every part of this code, we'd be here for at least another hour. And I think as opposed to like the OAuth stream that we did before, I hope you're saying that at least for part one of the stream today, this is actually a relatively easy kind of concept. The hardest part here is just kind of conceptually thinking through like what do I actually want to capture, what's important to me, and then actually writing all this code. And you'll notice here, like pretty much like almost like 95% of the code that we've written so far has all been like very specific to OpenTelemetry. We've not really done hardly anything at all to support the business process itself, or the business process being the fulfillment of the pizza orders. So yeah. All right. So I guess I should say we're going to actually take a couple different steps here whenever we actually want to what the business process is. So first thing we're going to do is we're going to normalize the order. And by normalize the order, I mean that we're going to make sure that the order is adhering to the data model and like the format that we would expect. Then we are going to calculate the price of the pizzas. So basically taking the orders that we're going to receive and then match them against our menu, find out what our subtotal is going to be. Then we're going to estimate the prepared. We're going to estimate the timing. And so I have like with the assistance of the AI, I have like this fake algorithm that kind of determines how long it would take to cook the pizza. So for example, if it's like a deep dish pizza, we're adding time to it. If it's a thin crust pizza, we're going to not add as much time. If there's extra toppings, we're going to add extra time. Obviously, in a real world context, that's going to be widely ranging, but because this is a fake API, we're kind of just making it things up as we go. We're going to have a function that actually prepares the pizza. Now, we're not actually doing any real preparation here. The only thing that function is going to do is capture the telemetry again. We're going to bake the pizza, same idea, just capturing the telemetry. We're going to persist the order. So recall up here that we instantiated this little list up here. So this is where we're actually going to save the order. And again, in a real world context, you probably want to send that back to a database of some sort. And then finally, we're going to return the order summary back to the customer or the calling client representing the customer. All right, so let me switch back to my other notes here. All right, so we're going to say normalizing the order. Normalizing the pizza order. So we're going to say pizza order equals normalize order. Payload equals payload. Tracer equals tracer. Now, this is where the helpers start to come in, because you might notice the squiggly line. Where is this normalized order coming from? It's coming from the helpers, and we have not created this yet. So let me actually, here, I'm looking at my other screen here. Want to make sure that I can reference both. Okay, so I'm just going to copy, like I was saying, just as a compromise on time here, I am just going to copy and paste any helper function that we use. And let me move my face out of the way so we can see that code there. All right, so this is our order normalizer code. Now notice from the API, from the FastAPI script itself, we're passing in two things, the payload and the tracer. And I hope both of those kind of make sense. Naturally, we want to make use of the payload to actually return back the normalized pizza order, and we are going to make use of our tracer here to actually capture our respective spans. So you can see as part of this helper function here, so this normalize order helper function normalizes the pizza order details. So you can see here that we're basically taking the normalized version, we're just lowercasing everything in terms of the crust and the size, doing the same thing for the toppings, and then grabbing the quantity. So not doing hardly anything fancy here at all. But the other thing I want to call out here is that with our respective spans, So this would be a span here. We can actually set attributes associated to the spans, and so we can do that as simple as noting, okay, here's what think of like these as like key value pairs. So the keys here is going to be pizza.size. We're going to give it the normalized size, pizza.crust, the normalized crust, etc., and then we're going to return back the normalization of everything. So that is the normalization function there, and how we're applying telemetry with our tracer and applying attributes to our span there. And you can actually apply multiple things to a span. Like we're obviously set attributes, an extremely popular one. There are a couple of other ones. I can't remember what those others are off the top of my head, but for our stream today, we're going to be making use of the set attribute of a span quite heavily. Actually, I do need to do a couple of imports at the top of the script here. So let me go ahead and just copy and paste those in here really quick. So just adding a couple of basic things in here. Now, we do have to bring back in the logger. This is the same instance of the logger, though, because recall up here, where's our logger? Okay, yeah, right here. Basically, this is like as long as your Python context is running in the same, or your Python script is running in the same context, then this is both this line on the left here, line 55, and line 7 on the right here, are pointing to the same logger. Okay, so let's go back to our FastAPI script here. So we just finished normalizing the order. Now, what do we need to do? I need to get back to my notes. All right, we are going to, that seems, I'm looking at my other code here. I think that what I have here is a little bit redundant, but do I want to? Okay. Yeah, I'm going to, even though, so we actually set, we created this span called normalize order here. This is going to seem a little bit redundant, but I actually do want to make sure that we are setting the attributes of these things associated to this pizza order span as well. So basically, I want all this exact same stuff here that to be copied and pasted over here. And I actually am just going to copy and paste this because, again, I want to save on time. And I think conceptually speaking, we've kind of covered everything that we're going to, at least for today. So we're going to set specific attributes to our current span. So again, same idea, setting the pizza.crust, pizza.quantity, pizza.size, etc. And then we're going to keep moving on. So now let's move on to calculating the price per pizza and subtotal. So we're going to say price per pizza, price per pizza, subtotal. I can even feel my voice starting to go. We're going to say calculate price. This is going to be another helper function that we're going to be making use of. Pizza order, tracer equals tracer. All right, so let's go ahead and copy and paste in this other calculate price function. Highlight all that. All right, let's move it over here. Okay, so this is our calculate price function. So again, we are setting another span here called calculate price. And then in terms of the price calculations, I mean, this is pretty basic. We're basically just you'll notice that we are accepting the menu as an input. Did I not? Looks like I might have missed that. Yeah, I should have also included another thing in here. Menu equals pizza menu as another input. But basically, coming back to our menu here, we're basically just taking the order, finding the values associated here, and just simply adding them up. That's what this code here is doing. So I'm not going to cover that more in depth, but you can see here that we are again applying the telemetry by adding our span to our trace, and also doing a little bit of logging here and setting of attributes to our span. So again, nothing particularly special. So let's keep moving on then. We are going to next calculating the prep time, bake time. Well, I should say not calculating, estimating the prep time, bake time, and the total time. So we're going to say prep time, bake time, total time equals estimate timing. This is going to be another one of our helper functions that we're going to paste in on the right. So we're going to say order as inputs order, equals pizza order, and tracer equals tracer. Basically, every single one of these helper functions, we're gonna accept the tracer as an input. All right, so we got another one that we gotta copy paste in. All right, so estimate timing, and this is gonna be that like little algorithm that I was talking about that kind of helps to estimate the time. Can't talk right now, Mom. Sorry, I will call back later. Watch the live stream, Mom. All right. Okay. Sorry. Got distracted there. I've never had that happen. I'm kind of surprised that's never actually happened before. Because my mom does call me, like, every day. It's never happened on stream before, though. Okay. Estimate timing here. All right. So, again, doing the typical OpenTelemetry stuff. But you can see here, this is how this is just like a simple algorithm for how we're actually estimating the time. There's nothing fancy here. Just, this is all proprietary stuff. In real life, you're probably going to have some different mechanisms to track bake time and prep time, but we're going to keep things super simple here with a very basic calculation, and then we're going to round our time to 2 decimal places because we're doing float values here again, and and then doing a little bit of logging and then returning these things back out, which we have done here. Okay, so let's keep moving on then. All right, so now let's calculate the price of the per pizza and subtotal. Calculating the price per pizza and subtotal. We're going to say price per pizza subtotal. Another helper function we're going to paste in here, calculate price. Order equals pizza order. Menu equals pizza menu. Tracer equals tracer. Yeah, got a typo there. Calculate price. Is that right? Wait, no. We already did that. Yeah, we already did that. What am I doing? Okay. All right, so we need to actually bake the pizza and prep the pizza. I'm actually just going to start copying and pasting. Sorry, that phone call from my mom kind of distracted me because she doesn't generally call in the middle of the day like this unless she actually needed something, so I'm hoping that she doesn't need anything. But we shall see. She may have called my wife if she actually really needed something. All right. These next 2 functions really do nothing. Like the pizza and the bake. So I'm just gonna cut. Well, they're kind of long. I can only paste in one at a time. All right. So prepare pizza. It's really just the capture of the telemetry again. So we're capturing the telemetry here. But there's nothing else going on. So you can see here with prepare pizza, we're just capturing we're setting some attributes on the span, and then we're doing a little bit of logger thing. And the same idea with the baked pizza. This is all just frivolous stuff. In reality, you would probably have extra logic beyond just this as well. All right, so baked pizza, same idea here. Records the pizza baking details for observability. Just setting attributes again, bake time. And yeah. Okay. So that's those pieces. So let's keep moving on then. Let's create a fake order ID, and we're going to keep it super simple. Setting a simple order ID. Order ID equals, so basically the length of the pizza orders plus 1. So you can imagine at the outset, there's not going to be anything in there. So the first ID would be 1. Well, let's say we had more than, why is that not syntax? Pizza orders, that's why. Forgotten S there on the end. All right, so that's the order ID. Now let's create, I'm just going to copy and paste this in here just for time's sake. Let's create a summary of what we intend to return back to the user. So this is going to be everything that we're returning back to the user. We're giving them the order ID, size, toppings, crust, quantity, price per pizza, subtotal, prep time in seconds, prep time, bake time in seconds, total estimated time in seconds, and a status that says ready for pickup. Because apparently we don't have delivery at this pizza place. And then finally we're going to persist the order. So we're going to say persisting the order. So this is just simply adding the order to the orders. So we're going to say persisting the order. We're going to say persist order. order summary equals order summary, orders equals pizza orders, tracer equals tracer. The reason I'm pausing there for a second is I'm beginning to think I actually didn't write this helper function correctly. Okay, because it's not returning back the orders, and I think I did need to add that. So all right, so anyway, so here is our helper function for persisting the pizza order. So basically, we are just appending the order to the order summary to the orders, setting some attributes, logging some info. Basically, that's all it. I think I may have done something wrong here, though. I think what I actually wanted to do is add a return statement here that actually returns back orders and then save it out here. But yeah. Yes, Kevin. I see your comment there. Okay. All right. Helper. All right. So we're actually done with the helpers file now. Those were all of our helpers that we wanted to add here. So let's just recap really quickly here. This post endpoint. Let me move my face back over to the right. So we have. We're starting up our OTel span. We're doing a little bit of logging. We're normalizing the order. We're adding some attributes to this particular span. We're calculating the price per pizza and the subtotal. We're estimating the timing of the prep time, bake time, and the total time. We're doing this fake simulation of preparing and baking the pizza, but that's really just doing a little bit of OpenTelemetry capture. We're creating a simple order ID based off the length of the pizza orders collectively. Finally creating this whole order summary and persisting the order. Finally, our last thing that we need to do, I think, is just simply return the... Oh, no. I forgot about all the counters that we need to increment. Okay, I am just going to copy and paste the rest of this because this is starting to get long in the tooth. This stream is. So recall these counters that we set up at the top here. We need to manually increment all of these. And it's pretty easy and straightforward, but there's a lot of typing here. So I am not going to do that. So that's the first couple. I'll talk through these though, really quick. All right, I got the counters. Now let me get the histogram things. Okay, so let me start back up here. So we're incrementing the pizza order counter. So we're basically just taking the pizza order and then incrementing them by the quantity, the amounts. We're applying a couple of different attributes here. Same with the revenue counter. We're incrementing it by the subtotal. We are updating the histogram object by with the subtotal. I'm not sure why these didn't necessarily paste in correctly, but we're also updating these histograms representing the prep time and the bake time. We're doing a little bit of logging, and finally, we are returning our pizza order response based off of that summary, and that ends the post endpoint. So finally, we do have the our last get stats endpoint, and I'm just because we are approaching an hour and a half already, and we still have a little bit of things to do left, I'm just gonna paste in this last get endpoint. I know this has probably been a little bit lazy of me, but there's, as you could see here, we're already at 350 lines of code here within this this API script, and that's not even to mention the helpers. The helpers ended up being another 250. We would have just been here way too long if we would have just manually typed that all out. So I apologize for if you felt like I got short shrifted a little bit, but a lot of this is repetitive. It's the same thing over and over and over. Okay, so let's just talk through this last endpoint today. Oops, I'm sorry. So get stats endpoint. So basically just getting statistics from all these things. So we're calculating the total number of orders, calculating the total revenue, total number of pizzas that we sold, average order, just doing a couple of different set attributes in our span again, logging some information, and then returning this back to the general statistics back to the users. All right, so that is our full FastAPI script. Now, I did create a unit testing script for this. So, and again, it's another one of those things where I just don't want to have to type everything again. So I'm going to go over here. I'm going to show you. So this is it, but I am going to go ahead and make a different one. I'm going to say stream test pizza. No, yeah, I'm going to put it here. It's test pizza API.py, and by and large this should be the same. I just need to update specifically here, so I'm going to change that to stream And then sample orders. All right, so that's fine. Sample stream. All right, I think that's everything I needed to change in here. But this is not necessarily anything fancy. And to be honest, I just use because if well, what do I want to say here? I'm not very good about writing unit tests, or at least historically I wasn't, just because I don't like to. I just like to use Bash scripts instead. But so I just use generative AI to help me, or like GitHub Copilot specifically to help me write this unit testing script here. And it's got all these different PyTest fixtures and such. I hope this works out of the box without me having to change anything else in here. And I don't think it should be. I think it should work just fine. But I do want to call out that under the sample data here, I do have a bunch of different fake orders that I had simulated here as part of this JSON. So ideally here, this should just work. Let's hope it does. So we're going to go into test / unit test, and then I'm going to do PyTest test stream. What did I call it? Oh, stream test. My apologies. Stream test. All right. Found not found. Okay. I must have pizza API. Okay. Pizza API.p1. Oh, okay. Yeah. Stream. Okay. Now let's try that again. All right, looks like I messed something else up in here. What did I mess with? Missing information. All right, looks like 3 of our tests passed, but this is probably some silly. Oh yeah, this await call next thing. What is that await call next thing? Let me see. Here, let me check my notes down here. I think everything should work. It's just I probably just made some silly syntax errors. Next. You can probably hear my kids screaming upstairs. I took today off work because they're on spring break right now, and I think they've been driving. Like, we love our kids, of course, but I think they've been driving my wife crazy, so I played with them all morning to give my wife a break. Okay, all right, this await call next. Where did the call next come from? Call next. All right, stream pizza API, middleware, call next. All right, I'm gonna start to get even more lazy here. I'm gonna just take this. And I'm going to go into here. I'm going to say, help me fix this. All right. We're going to get a little bit of AI friendly help here. All right. Oh, looks like I had a silly typo in there, maybe. Allow J. Oops. One hidden. Okay, looks like it's passing now. All right, we'll give it a second, and then we'll run it ourselves here one last time. We are just about done here today, folks, and then we will pick up in part 2 next time. All right. So now it looks like we're probably good. So let's try to run this ourselves one last time. PyTest. Stream API test. Now we're getting a pass on everything. So that means everything is working. So let me go ahead and push up all of this stuff. So pushing up the contents from the part 1 live stream. Okay. And then we will pick up with this code in the next stream. But now you can see, if you'd like to go back and view any of this, that it's all up here. So all of our stream code is going to be right here, everything that we wrote today. Okay, that is all I want to cover for today. So like I was saying, we covered how we actually apply all this stuff to our specific FastAPI Python script. Now we need to, with the next stream, we need to get the telemetry from point A to point B, and that's what we're going to focus on next time. All right, hope you all enjoyed this stream. I am going to log off for now, and I hope you all enjoy the rest of your day and the rest of your weekend. See y'all later.